Chapter 2, Lesson 1 of Pre-Calculus, and in this video we're going to look at the vertex form of a quadratic expression. Quadratic, you remember, is f of x is equal to x squared, and it looks like a parabola. However, if we move it right or left, which would show up in here, and up or down, which would show up out here, and we vertically stretch it or shrink it, that's going to change the formula. So this would be the vertex form, and the reason that we want to use vertex form is because it gives us some information very quickly. It makes identifying the vertex very quick and easy because we know the x-coordinate is going to be the shift right or left. So that's going to be the x-coordinate here is going to be this number here, which we call h. And then the y-coordinate of the vertex is going to be this value out here because that's the shift up or down. It also helps us to identify the axis, which is the line that goes down the center of the parabola. And it also makes it very easy to sketch a graph. When we're in standard form, ax squared plus bx plus c, that really doesn't give us a lot of information. However, vertex form makes these three things much easier to identify and to use. So standard form is ax squared plus bx plus c, and vertex form is this. Now, how do we figure out the value of h, the value of k, and the value of a? And that really is the crux of the issue here. We already know that this is y, and we already know that this is x. All of these other values do something to the value of x in order to produce the value y. So what we need to do is to know what each one of these letters represent, and then how do we calculate the value that goes in for each of these letters that are not y or x. So if you look down here, there's a little discussion that tells how you calculate each one of these. So the vertex is going to be hk. So remember, the vertex is actually the coordinate. So normally our coordinates are x, we have an x coordinate, and we have a y coordinate. But if we were to put an x in this expression and a y in this expression, it'd be very difficult to determine, well, which x is the vertex and which x is the relationship or dependent variable. So we use h instead of x. That's why we have h here. And we use k instead of y for this value here. So the ordered pair hk is actually the x and y coordinate of the vertex. So you can see, while it's in vertex form, it's very easy to know where the vertex is because I have the x-coordinate here and the y-coordinate here, which is simply correspond to the horizontal shift and the vertical shift. Now, the axis goes through the vertex, so the x value of the vertex is also the axis of symmetry. So x equals whatever that h value is will be the axis of symmetry. So if we're given the standard form ax squared plus bx plus c, how do we calculate the value of h, or where does the vertex come from? You remember from last year, hopefully, that the opposite of b over 2a will give us the x value of the vertex, so that's going to be the h. We then last year substituted that x value into the expression and then solved it for y in order to calculate the y value of the vertex. Well, this year we have a little formula that we could use that would be a little bit easier to use, especially when we're dealing with fractions, and that is this. We can calculate the k value by doing c minus a times h squared. So after we've determined h, we can substitute that in the formula. The a and the c come from standard form, and then we just simply make that calculation, so that will give us the h value, the k value or the y value of the vertex. The a value that goes here in vertex form comes from the a value in the standard form. So all of our information, the calculations, are all wrapped up in this. So let me give you a visual that maybe this will help you, and maybe you can write this down as a little chart to help you out. So this is vertex form. All right. The a value we get from the a that's in the standard form of the equation. So the a that goes here in vertex form is simply the same a value that is in standard form. The h value we get from calculating the opposite of b over 2a. So again, from standard form, we take the b value and the a value substituted in. That gives us the h value, which goes into this form. And again, that also corresponds to the x value of the vertex. The k we can calculate by doing c minus a h squared. Again, the c and the a coming from the standard form. Or if you wanted to, you could just substitute the opposite of b over 2a, which is the x value, into the expression, the standard form for each x value, and then solve it, and that would get your y value or your k. So these are the three things that you need to know from vertex form. You need to know how to calculate those and then substitute them into the equation. All right, so that's all you need to do. I'm not going to do any examples. I will do some examples on the next video. So check out the next video on how to actually substitute those in and put an expression in vertex form.